right. Hello. If you didn't know it, this talk is going to be in English. Puedo hacer español también, but they asked me to do it in English. Okay? I'll speak slowly as much as I can. You can ask questions in Spanish at the end if you want, and come back to see me and asking questions in Spanish as well. But we'll get started in English. So my name is Isabelle. I'm a CTO at a company called 42Crunch. I was delivering an API security platform. And I'm here today to talk to you about tips for API security. So if you looked at the program, it says 5 tips. If you look behind me, it says 10 tips. So you have gained 5 in the middle, right? You get 10 for the price of 5. And the reason is, in between the time I presented this talk for Codemotion and now, something has happened, which is that there is a specific OWASP threat list for APIs that has 10 entries. So this is what we're going to talk about today, okay? So in case you have missed the news, APIs are really now the new entry point into your companies, into your data, your processes, and it's becoming a very important threat factor. So who here is looking at APIsecurity.io, receiving the newsletter and seeing the news? Do you guys know that? A few of you, okay? This is something we curate. It's like a newsletter on API security. It's completely free. It's a community effort. And in the past, almost year now, every single day, the gentleman who basically manages this newsletter has found a new breach to explain and push to the public. So it's like every single day, pretty much, working day. And basically, what causes that? And this is what we are going to talk about in this session. Basically, input validation problems, right? Data validation problems. Some bad configuration of your systems. It can be the APIs, but it can be the underlying systems as well, like the machines, the containers, Kubernetes. There's a lot of different things that can go wrong here. And some data and exception leakage, some information that should not leak out, and that is leaking and giving me information that people can exploit to hack your APIs, right? So as I was mentioning, finally, and I'm saying finally because we've been fighting for the past 3 years as part of my company, saying, well, the current OWASP, so you heard about OWASP, you know what OWASP is? Most of you, right? So you all heard about the OWASP top 10. So the OWASP top 10 that was available and is available right now, and the most known one is about web applications. And we were saying, yes, there is some overlap between web application and APIs, but APIs really deserve their own list because a whole bunch of problems which are not applicable to web applications and how you write the user interface, for example, and servlets and all kind of different ways of writing a web app. And we need something specific for APIs, right? So this is out now since the beginning of the summer. This is work in progress. The goal is to release the official list by the end of the year. We're working with the people working on that. There is a link here in the presentation on the current draft, and that's what we're going to talk about now. But before we get into this, I just wanted to set the picture on what we're talking about here, simply because of terms, okay? So my recommendation in terms of an architecture of any application will be the picture which is behind me, which is we have data that we want to expose, right? Now, that data you should never expose straight into any consumer. I don't care if they're internal consumers or external consumers. You should never have a direct link from your front, from your application front, all the way to the data. That is very dangerous and is the source for many, many different problems. We'll get into that, right? Now, what you should really have is a layer in the middle. You know, people here who've been doing this job for some time, you know what the MVC model is, Model View Controller, right? This is still applying. It's a very good principle of having data, having a view, and having a layer in the middle, which is a process or controller layer that will allow you to expose that data in a certain way for the consumers of that information, okay? So in terms of architecture, the traffic that goes from the clients all the way to that data is called north-south traffic. I don't know why, but that's the way it is, okay? North-south is this way. Now, with the new architectures based on microservices, etc., there's a new type of traffic that's emerging, which is east-west. What this is microservices talking to each other to basically deliver information, processing, etc., right? So this is not the client calling into that data, it's the microservices calling each other, right? And you need to protect that traffic the same way you would protect north-south. So north-south traffic, east-west traffic, if you're using microservices, you have to protect both ways, right? Something very important, you never jump, as I was mentioning, straight from the front all the way to the data, right? You have to go through all those layers, encrypt everything between those layers. So those are like a basic architectural principles that would need to be followed. Now, let's talk about those OWASP problems. So in order to illustrate each of those problems, I'm going to use an application which is called Pixie. Pixie is, actually, we're looking at renaming it to Crappy, if you know this, the CR API, like the worst API in the world, right? And the idea is to put in a single API all the problems that we see on the field and all the type of attacks, right? So it's a really bad API. It has all the problems in a single place, but it's very useful to illustrate the problems and what we find, right? So you have access to that, you have the source code, you can see how it works. So how does OWASP work, right? So there's A1 to A10, right? The order is not innocent. The order is by order of problems, of the number of times this is actually occurring. So it actually goes from most critical to least critical in a sense, right? So the most critical of them all, right, is A1, and it's called object level access control. So I've renamed that, just for the explanation, as extraction via enumeration. And the idea of this is you have an API that allows you to retrieve some information, and let's say it's a user ID, right? Or in the example here, it's a shop ID, doesn't matter. So you have an ID that uniquely identifies some information. It can be a user, it can be a catalog entry, whatever it is. And this ID, which usually are internal IDs, is exposed to the outside world, which basically opens the door to guessing, right? So if I'm somebody and I'm calling get/user/123, right? And 123 is my ID, I'm going to say, what happens if I put get/user/124, right? And see if that works, right? And if you think this is, as I said, this is number one. And what happens here is, what we're missing is some authorization on, okay, I'm Isabelle, I'm user 123, therefore I should only be allowed to access my data, the data from user 123. Are we validating this, right? And a real breach of that happened with T-Mobile about 2 years ago. Basically what happened to them is they have their ID of a user, as you can imagine, is a phone number. So T-Mobile is like Movistar or something like this here, right? So they would have this API call that you say get profile or something like this with a phone number. And what happened is if you put the phone number of your neighbor, it would work as well. And you would get all information about your neighbor's profile, including some pretty personal information. Okay, type PII, type information, private information that should never leak. And what happened there is if you had a valid token, so you will authorize to actually talk to the API, then you will be able to put any number you wanted, right? So number one problem, how do I fix that? Basically by authorization validation. You have to go and making sure that the user is actually allowed to access the data. Number two, which might be even easier to do as a first step, is to use non-guessable IDs. So instead of using user 123, I'm going to use a UID, so a unique ID for that resource, whatever that resource is, right? And that's what I'm going to expose outside. So it doesn't mean that inside your, say you have a database and you have sequenced IDs for your users or for whatever resource, right? That's fine, that's your internal stuff. But seen outside, you want to dereference that and use a UUID instead and keep somewhere saying, yeah, that user has that UUID. And that's exposed outside, that's all fine, because it's basically impossible to guess another UUID. Right? So even if somebody tries, they won't be able to get any types of data, right? So in our Pixie, what happens is, whenever we work with the user, right? So what Pixie is doing, is something to, it's an application to manage photo sharing, okay? So that application, you start it, and it allows you to log in, and then to actually register a new user as well. So, and if you get the profile for yourself, your user info based on your authentication, you'll get something like this. So we'll talk about the rest of the problems after, but the one that is important here is this, right? ID 44. If I have ID 44 as this user, I'm probably guessing there's a 43, 42 all the way down, okay? So, and that's exactly what happens here. So I can override that number. We'll see that in a minute, and I'll show you in the demo. I can override that number and get the information for somebody else, okay? I'll show you that in a minute after talking about another problem. That's number one, okay? So yes, based on another problem I'm going to talk after, we can override that number and get the data for another user. I'll show you that in a minute, okay? Now, related is A2, which is broken authentication, okay? So basically, something very critical for you all to understand is access tokens, and especially if you have retrieved them through auth, etc., right, are not authentication mechanisms, despite the name, right? All right. So think of this as an hotel card. You go to a hotel, you go to the reception, right? You present your passport, your ID, your reservation, you get a key, right? So at that moment, you have demonstrated, you have proved who you were. You had to authenticate to get that key, right? But now you can take that key, you can give it to your spouse, you can give it to your friend, and they can still open the door of the hotel, right? So once this process is over, presenting that token is by no means a proof of who the person is. So it's not a proof of authentication. So I can steal a token that is perfectly valid, and I can present it, and basically it will still work because that token is absolutely valid, right? So you have to take extra measure on top of just presenting a token to prove who is actually talking to you, right? And what are the problems with that? So there's multiple. The problem of a token being stolen can be a little problem or a very big problem depending on how you're using those tokens and what people are allowed to do with that token, okay? So if you have a single token for every single API in your enterprise, so like if I get a token and I can call absolutely any API I want, that's a big problem, okay? If I can call from any application, that is a big problem. If I can do any operation, that is a big problem, okay? So what I mean by that is you need to restrict what that token allows you to do, right? So in the OAuth world, there is something called scopes, right? That's an attempt to do that, to say, okay, you're going to obtain a token, but with that token, you can only call that operation, that operation, that operation, not the others. So even if that token gets stolen and I'm trying to use it for something else, I will not be able to do it because the scope of that token is not adequate, right? However, scopes are only an operation protection. That means it allows me to access get/foo, right? Or not, depending on what I obtain. But it does not say anything about the data. So again, if I have an operation that's get/foo/123, right? if I have access to get/foo, I can also do get/foo/425, right? Because auth doesn't say anything, scopes don't say anything about the data I'm allowed to access. And for that, you have to put in place more fine-grained authorization mechanisms, back to what A1 is saying as well. Every time I'm receiving a request, I have to make sure, one way or another, it can be looking at the role of the person, it can be some specific service that tells me yes, no, depending on what the data is and who the user is. You need something a bit more fine-grained to also define, do I have access to that data? Not just to the operation, but to the data itself, right? So that's very critical. And the other aspect is make sure your tokens are short-lived, right? So I worked with a customer a few years ago where what they had done is they were using access tokens, so issued by auth. So let me step back for a second here. If you use API keys, right, usually the big difference between an API key and a token, an access token delivered by auth, is one does not expire, and access tokens have been created to expire. So when you obtain a token, you get a token for 1 hour. And when that token expires, they have to refresh it, get another one. So if somebody steals it, they'll basically have a window of 1 hour to do something with it. An API key does not expire. It doesn't have any expiration attached to it, right? So it's like there forever. That's why a lot of people like to use that, because it's easier also for mobile application to actually access APIs with something that doesn't expire. It's the way to obtain a token is more complicated to code than if you use an API key. But of course, there is a risk with it. Now, if you use OAuth and you give people tokens for 6 months, that is not, you might as well use an API key, right? I've seen that in a customer, somebody who did that. Why? Because they had a mobile application that they were refreshing on the stores every 6 months. And to make things easier, they just generated a token for 6 months validity and hard-coded that into the application, right? So that you might as well just put that in there, the string. You know, anybody will decompile that, see that information, so you don't want to do that, right? If you're going to work with auth and access tokens, then use properly all the expiration mechanisms that it provides to you, okay? So, yeah, that's A2, okay? So, at a high level, authorization, fine-grained authorization, manage the life cycle and the life expectancy of your token is very important. Now, A3, this is about data leakage. So this is about an application returning too much information in case of problems or not even, okay? So we'll take 2 examples here. The first one is our friend Pixie. So our friend Pixie is doing 2 things. It gives you people's passwords, which is not a good idea, right? And the reason it's doing that is because in the code, what it does, it's just taking and doing a request on a MongoDB database and takes the entire user object, sticks that into a token, and then returns it to you as authentication, okay? So you have all that information in there. And the other thing we'll talk about is this is-admin, and we'll come back to that a bit later. That's too much information as well. And the other thing it does is if it fails, it sends you this beautiful exception, right? That tells me this is Node.js on the back end. That tells me it's using MongoDB, right? And there it turns out that, okay, let's see if there are some specific vulnerabilities I can exploit there. The most obvious one for MongoDB, right? Anybody using MongoDB here? Few people? Have you all changed the default ports on which it runs? Same thing applies to Elasticsearch, by the way, right? So one of the key issues here is in this setup. So it's not only the API, it's the setup around it. The MongoDB default admin port is still the same, and by default, it is not secured. So there is no user password to access the console. So I can go to localhost and 28017, if I remember well, and I will get the console of MongoDB giving me all the information and all the data, et cetera, right? That's the kind of thing. So see, those problems, they work all together, right? When somebody is trying to break an API, it's not one thing which is going to give them some hints. It's the combination of things, right? So they will try to send all kind of bad stuff to your API, see how it reacts. If it sends back an exception, you use that to maybe find another entry door, right, into the system. So it's the combination of problems which is really critical, not just in general one single problem individually, okay? And then a real example. So in the presentation I also have some real things that have happened. So it's a bit old, but it's a kind of a school example. That's why I'm using it all the time, which is N26. Okay, so back, again, about 2 years ago, a student doing a thesis on security in Germany cracked open the APIs from N26. And one of the things is he's found a lot of problems, right? But one of the problems that he found was basically, and if anybody here has a N26 card, where you can check, in the back of your card there is a number which is like a master ID number. And apparently, as an N26 customer, what you have to do is you have to give as a proof that you have physically the card when you call support and customer service, right? Now, somebody building the API got the good idea of basically embedding that master ID in every single response, right? How did that happen? So basically, there's probably an internal data that got returned. The gentleman who was hacking the API realized that because he had an N26 card, and he matched that number behind to what was returned by the API, basically, and that's how he found it. So then, basically after that, it was game over, which means like he called support, he was able to change all the passwords, get access to the account. That was it, right? So very, very careful on how you basically return data. Now, how do you detect such stuff? That is not easy, right? The way to detect such problems will be to put some filtering in place of your data. Whatever will work for N26 is maybe not going to work for you. What is the sensitive data that you manipulate, right? And making sure that that information can never leave through the API unless you want to in a certain way, but it shouldn't. So you have to put in place some filtering, some, again, authorization, but on the response this time, if you want, right? Looking at the response and saying, does that contain some sensitive information that should never be there, right? Like the password in the case of Pixie, right? So it's basically business enforcement you have to do to catch those errors. There's no magic firewall and click is going to do that for you, because this is like business data. So you have to know your business data, and you have to filter out based on that business data. Okay? A4. So this is about basically taking the system by overload because you're doing too many requests, okay? So it's rate limiting, basically, right? This is very common issue and requirement for maybe the API management gateways that you're using in your setup, okay? And basically allow you to exhaust the resources and exhaust the API. Now, I'm just going to switch over here to a really good example from Instagram from a few months ago, right? So on Instagram, somebody basically got, this is a bug bounty, so somebody who basically made money out of finding a problem. And what he found is when you try to reset your password on Instagram, you have to enter a 6-digit code that you receive on your phone. So obviously, if you don't have the phone, what you have to do is you have to guess the 6-digit number, right? And what they have done is they've put a limit of 200 attempts per minute per IP. So I've put a question mark here because I defy any of you to try to reset your password 200 times in a single minute manually. You will never do that. Be extremely complicated, right? The only way you can reach that limit effectively is by having something bombarding your system. But as a human, you will never do that, right? So first of all, there's a little problem with the limit itself here, and then it's by IP. Now, hackers have the same means than you and me have access to public clouds where you put a credit card number and you get thousands of machines running in one click, right? So the gentleman who actually found this problem, that's exactly what he did. He went to major cloud provider. He hired, I don't know how many, 1,000 machines, all with a different IP, right? And all the machines starting doing brute force attack to guess that 6-digit number, and he found it, okay? So again, depending on which operations, etc., you have to measure those rate limits by operation, not by API. Very likely you need different rate limits per operation in your API, right? And measure those. You probably want to have less on the post and the get, etc., right? Okay, A5. Blocking unauthorized call. We're back to the same thing, resource level access control. It's like, what am I authorized to see and do when I connect somewhere, right? And are there any things that you have left in an API that you don't expect people to use, such as, I've seen that many times, in the same API, I have admin function to manage users, for example, and non-admin functions, which are the ones I'm exposing outside. There's a single API, except I'm just telling people from outside, you can use those 4 operations, and you're telling the people from inside, well, you can use those operations, right? But they're in the same API, so if I call them from wherever, they're there, right? So, for example, mixing admin and non-admin all together, that's a very common example, right? So this is very easy to find because usually we're not very inventive with names, right? If we have admin function, I'm going to call it /admin, right? If we have users, we're going to call them /users. So we're not very inventive, right? So as we basically go and create our API, we have to be very clear on separating what we want people to see. We're back to that controller layer, right? So when somebody is calling you from outside, you want to block any calls that people are not supposed to do. So if I'm not an administrator, I have no business doing an admin call. So let's block that, right, automatically. So you want to make sure that people, if they're allowed to do a get, they cannot do a post, even if the API implementation supports posts, right? So it's there, it's running. If I call it, it's going to work. But I'm not allowed to do that, right? So you have to block all of that and making sure I actually cannot do that, right? And again, we're back to validating what the user has the right to do. So basically, trust no one, right? You don't trust any of the calls coming to you. You have to systematically validate who's calling you and if they have the right to do what they want to do. All right? So in Pixie, there's this really nice call that says API admin all users, that returns me all single users from MongoDB in a single call, right? And normally what happens is in the app, so Pixie is 2 aspects. There's an app, a UI, and there is the API, right? So if I go to the app and I'm trying to be admin, then it's going to block me. But if I go straight to the API, then it doesn't. So there's something I wanted to add in here. So I'll tell you a story that came out, like, I think 24 hours ago, right? A big breach on an application where the app is doing all the control and of the data. There was 0 authentication on the API, nothing, not even an API key, right? Nothing, and all access to everything, obviously. So by just discovering what the API was, which was very easy because they just decompiled the code of the application, which was a mobile app, they were able to extract absolutely every single piece of data. We're talking about 70 million of records, right? So don't do that. It's not because you have created an API that is only used, you think, by your own applications, that this API is not visible, right? The minute an API is used by a mobile app, it is public, It has a public endpoint I can reach from the internet, right? So it's public. And if it's public, you need to protect it the same way you would protect any open public API. Same thing. Just treat all your APIs as if they were public, and then you will have no problems. All right, mass assignment. So this is an interesting one. How do I basically update data by sending a bunch of JSON, right? I'm not supposed to actually do that. I should have a limited set of fields I can actually update. But if I override, no, in the case of Pixie, I'm supposed to only be able to do email, password, and name. Those are the things I can update. But if I put isAdmin equals true, then I'm going to become an admin, right? And usually I was showing this, and you were like telling me, you know, Isabelle, that's kind of a bit of an obvious one. It's kind of a bad one. Yeah, right? Okay, this one is from 3 days ago. Huge application, okay? Exactly the same problem as Pixie. I have in the code as admin role Boolean. If you're using the Harbor registry, this is where this is coming from, the Harbor Docker registry, okay? And that's exactly the problem that we have in Pixie, which is as admin role bool, and you can't see here, it's on the right, but actually they're nice enough in the code to tell us the JSON equivalent of that thing, which is add_admin role, right? And all the guy had to do was to send a JSON saying as admin role equals true, and the entire thing got updated, and it was an admin. Okay, so that's mass assignment. Read the actual report. Is very interesting on how they actually did this. Okay, so why is this happening? Because we are not controlling, we're trusting the data, and we're not controlling what people want from us, right? If I'm updating my profile, I have no business trying to make myself an administrator, right? So this should have never happened if, when this is received and you see that, you're like, I'm going to reject that call because that is not the payload I'm actually expecting. The payload I'm expecting is email, password, and name. I'm not expecting anything else, right? So I know it's easier for doing an update to just say, well, this is a full object and doing a put or a patch, right? But think of the model behind it and what would happen if you were putting some data that you're not expecting. So you have to handle this in your code, right? Making sure you actually stop this. This is a very interesting one. So before going any further, let me show you that Pixie thing. Okay? You'll see that even, yeah, it's pretty big, this thing, so. All right, so we'll register here. Oh, that is not right. Connection refused. Oh, damn it. Okay, we're not going to do that. Sorry, I stopped this thing. Okay, so I'm not going to show this. I'm sorry, I have no time. I'll show it to you afterwards when you come to see me. So I have only 5 minutes left. I can't actually show that to you if it's not started. All right. Security configuration, misconfiguration, that's A7. The most important one here, you all heard about this, is Equifax, right? What did the Equifax disaster happen? Is because there was this vulnerability in Apache struts, right? That was well known, and actually I was listening to a podcast a few days ago. A lot of companies got bitten by that problem, and got breached. But Equifax being who they are, especially in the US, right? They made up all the news about this, but many other people got bitten by that. And it was as simple as an existing problem in Apache struts, right? That had been fixed, that had been raised, but it didn't install the patch. Okay? So basically, what's really important here is security is only as strong as the weakest link, right? If you have vulnerabilities in the entire system, should it be a library you're using or anything else, then this is where the problem is going to be focused, okay? And that is especially true if you're using NPM, if you're using Node.js, right? Why is that? Because when you create an application in Node, what happens is you get some dependencies. You say, okay, I'm going to use this, this, and that, right? Each of those is dragging a lot of dependencies, and each of these dependencies is dragging much more. Right? In the case of Pixie, I think it's like 10 includes or require, and at the end there's like 600 libraries that end up being used, right? So some time ago, about a year ago, somebody got committer rights to one of the most famous NPM, very well used packages, overridden it with malicious code, pushed that as a new version, and basically this thing got downloaded 8 million times, 2 million downloads per week. That's like a hacker's dream come true, right? It's like, I don't even have to hack the code, it's people that install the hot code in their applications, right? So at the end of this, there were 8 million applications with that bad code in it, right? So what do you have to do here? I have this thing called SNCC, but the idea is you have to know what you're using, and you have to use automated tools to detect those problems, right? So in the case of Pixie, for example, I have this remarkable thing, right? How does that work? I'm in GitHub, I have a tool, like, can walk those dependencies that I was talking about, the 598 of them, right? And tell me, compare that against a database of known problems and tell me something is wrong in here, okay? So that's what's happening, and that's what you have to do. Whatever system you're using, whatever programming language you're using, I would really highly recommend you have an automated way of knowing what you're using and whether there are any vulnerabilities in it. Trying to track this manually is very complicated, if not impossible, okay? So, especially across an entire enterprise. So make sure you have there's plenty of tools, open source one, commercial ones that allow you to do this now, so you get the flag and you know what you have to do, okay? Injections, so this is very well known, back to the same thing. Why is this happening? This is happening because you're not validating inputs in your code. But back to slide number one, which is no trust. The data you receive, the tokens you receive, the information you receive, you don't trust and you validate systematically, right? So injections happen because I can put some bad characters in a string and get it in without any further ado. Why? Because we're not validating and we're trusting the information we receive. And again, it doesn't matter if the application is used internally or is used externally. Just, again, consider everything as public, no trust, whoever is using the API, so you validate absolutely everything. That's the core of basically injection catching, making sure that this is what you need. Right, so in the case of Pixie, for example, we have this username, password thing. So what is this actually doing, right, is it will say whatever happens in MongoDB, if I'm passing, this will be interpreted as any password, pretty much. So I don't even have to put a password. I will just get in and get an access token, all right? So you have to check for those things. This, you can hack yourself and check for those problems. And finally, quickly, improper asset management. So what this is about? This is about having APIs that you don't control. You have things that run somewhere in your company. You have open ports, open APIs. Maybe you forgot an old version you didn't remove. Maybe you have some dev versions or QA versions accessible from the actual internet. You basically need to know what you have to be able to protect it, okay? So this is really what this is all about. It's about governing the governance of your APIs, knowing their life cycle, being able to retire them when you don't need them, knowing what you have. That is really what this is all about, right? And again, today it's being said that the average number of APIs per company is 400, right? Average. What that means is there's no way you're going to validate all that stuff and manage all that stuff manually. You have to put in place automation, take a DevSecOps approach, so that whenever there's a new API, some pipeline kicks in, some magic happens, and you know if you have vulnerabilities, you're automatically hacking yourselves. You put that into somewhere where you have them governed. When you're retiring them, same thing, it happens automatically. You have to automate that stuff. Step by step, right? There's a lot to do this properly. But you can adopt step by step what you have to do in order to properly manage and retire your APIs. That's very critical. Okay, and finally, but not least, but not last, is logging and monitoring, right? You cannot secure, you cannot track what you don't know, and basically what it means is every single transaction, everything you do on your API systems needs to be logged somewhere. That may mean pushing your logs to something like an Elasticsearch or to a Splunk or this type of tools. So your logging is actually analyzed, right? But you also have to be careful about what you put in the logs, right? Very good example, again, in here, right, from our Pixie friends. So where I have directly the thing that allows me to put I have the token, whatever is used to validate that token, the passwords, the user IDs, all the information. That's all in there, right? So you don't want to do that. I know it's very useful to put this stuff in logs for debugging purposes, but then what you have to do is to redact those, right? So instead of putting here the full token, just put the first 20 characters. It will still be useful for debugging because those 20 characters will be unique. So if you look for them, you're going to find them, and you can do debug. But if somebody comes across those logs, that information is useless, right? Because they don't have the full piece of information. So that's critical, right? And another thing that's a very key problem, right? Remember that if you pass a key or anything sensitive in the URL, it will go straight into access logs, into logs that record the traffic, right? Plus, it can be very easily seen in a developer tools or anything like this. So you want to use headers instead and use the default headers for that instead, okay? All right, so basically, call to action, right? Trust no one. That's my call to action, right? If everybody was just looking at the data they receive through APIs and not trust it and validate the data, validate the token, validate who's calling me, making sure they have the right to do what they have the right to do, okay? 99% of the problems would be gone. That's the key call to action, right? And if you have any sensitive data, as Mr. Werner Vogels is saying, dance like no one is watching, encrypt like everyone is, which basically means like, you know, don't trust again. And if you're manipulating any sensitive data, make sure it's all gone and encrypted, okay? Sorry, I went over by 5 minutes. Thank you very, very much for coming this morning. I'm sorry about the demo. I'll fix that in a second. I'll be here all day as well as tomorrow. So if you have any questions, please feel free to stop by and ask. Thank you very much. Have a great lunch.